Hey guys, welcome. We're going to do concentration in this one, right? And so when we talk about concentration, we're talking about how much solute is in how much either solvent or volume. So how much of this compound is in this much water or whatever the solution may be, right? And so concentration, right? It's concentration, it's a ratio. It's right, a ratio. And solute to solvent or solute to volume. So what we're going to start with is molarity. And molarity is probably the most common, right? So molarity is probably most common. All right. It's moles of solute, liters of solution. It can also be millimoles of solute per milliliters. All right, because if you type the top divided by 1,000, the bottom by 1,000 works. So if you have small concentrations, right, millimoles per milliliter works just nice too. Now this one is also temperature dependent. And why is it temperature dependent? Well, because the volume is temperature dependent, right? But what we like about this, all right, when we use molarity in lab, when we measure a volume is an amount. So I can take volume times molarity and I get moles, right? We like that. We like volume times molarity and you get your moles. So that's why we like this one, right? So we have an amount of volume times a molarity, we get moles. And because reactions happen in moles, it's nice. Okay? All right? So molarity by far is our most common, in especially in the general chemistry lab. Number 2 is molality, little m. Typically it's italicized. All right? This one is temperature independent. All right? Because mass does not depend on temperature at all. All right? So molality, when we have low concentrations, so a low molarity and a low molality, they're very much the same number. Like 0.05 molar, it's very close to 0.05 mol. All right? But as you go, like, 2 molar, 3 molar, 4 molar solutions, your molality is going to be a lot different too. All right? Because it's kilograms of solvent. So for molarity, this solution, this is the total volume. Right? Total volume. Whereas molality, it's the mass of the solvent. So 5 kilograms of water, 1 kilogram of water, 250 grams or 0.25 kilograms of water, right? However much you're adding. Now, molality is typically not used unless the experiment, right, has a temperature change. Right, because if the temperature changes, the molarity would change, right? So if you start at 30 degrees Celsius and you get cooled down to 2 degrees Celsius, well, that volume changed a lot, all right? But if you have 30 degrees Celsius water and it goes down to 2 degrees Celsius, the mass is the same. So that's why we use molality, right? Another one we use is mass percent, which again is temperature independent because it's mass. So mass percent, mass of solute per mass of solution, right? Now that's the total mass, right? Not just the mass of the solvent. So only this one's the mass of solvent. Mass percent, this is mass of solution, the whole thing. And again, these are all ratios. If you've been to the hospital and get an IV, right? And there's different IV bags. 5% blood sugar or dextrose, which is a glucose. You have 0.9% NaCl. And those are just two of many examples, all right, that are used. Okay? And so it's the mass of the solute over the mass of the whole solution. Now, if they're very dilute, right? If we're dilute, okay, which that means there's not a lot of solute there, very dilute. Parts per million is a mass percent. This is mass of solute divided by mass of solution times a million, right? 10 to the 6 is a million. And a lot of times we can put these out as milligrams of solute per kilogram of solvent. All right? Or, right, and how does that work? Well, milli is 10 to the minus 3. Kilo is 10 to the positive 3. So the 3. So that difference here is 10 to the 6. All right, that's your million. Or it could be milligrams of solute per liter. All right, and right, volume. Let's just put volume in liter. Because it's so dilute, we're assuming the volume doesn't change much because the substance is in there. And then again, the liter of water is like a kilogram of water, right? If we use the density of 1. Parts per billion, right? The same thing. You could use micrograms of solute per kilogram of solvent. All right? It's a small amount. Okay? And lastly, mole fraction. That's chi, the Greek letter. The Greek, like X, chi, mole fraction of I for total moles. This is typically for gases. Right? Because gases, they don't have a fixed shape and they don't have a fixed volume. But the number of particles, right, you can get the mole fraction and you can do a lot with the mole fraction. So those are the units of concentration we will be using. Feel free to reach out if you have any questions, and we'll see you next time, guys. Take care.